Hey guys, welcome to the lesson on experimental probability. This is a little bit different than theoretical probability because experimental probability looks at the chance of an event happening, but it is based on previous events. So it's not like what could happen. It's based on what has actually happened. What have we seen in the past? And so based on that, what could we see coming up next? This happens a lot in sports when they talk about experimental probability. Batting average is experimental probability. It changes every time a batter steps up to the plate and either strikes out or hits the ball. It changes every time a goalie is in net and they play a game. Their save percentage changes and whatnot. That's experimental probability. Those probabilities that change based on what has happened in history. And it's also based on what actually happens. An example, every year Tim Hortons has roll up the rim, and this year the odds were 1 in 6 wins. And the question I always ask is, does this mean if I buy 6 coffees, I'm going to have one winner? And I get a lot of students who say, no way, I've bought 10 coffees and I haven't got a winner. You see it when you actually do it. Yes, theoretically, there are probably enough winners on the cups that every 1 cup per 6 is a winner, but it doesn't necessarily mean that if you buy 6, you're going to win one. You could buy 6 and they could all be winners. You could buy 6 and none of them could be winners. It just depends on what actually happens to you. So that is the difference between experimental probability and theoretical probability. So let's take a look. Some students are creating a board game. They think about making a rule that you can only start moving your piece when you roll a 6. What is the theoretical probability of rolling a 6 with a die? Express your answer as a fraction and a decimal. So the theoretical probability of rolling a 6... My phone rang and I had to go get it. The theoretical probability of rolling a 6 is 1 in 6 because there are 6 sides to the die. Express your answer as a fraction and as a decimal. So if I put that as a decimal, 1 divided by 6 is 0.166 repeating. Let's say that you were to roll a die 50 times. How many times do you think you would roll a 6? Explain your thinking. So if you think about it, if you roll it 50 times, if you take this percentage and times it by 50, I get approximately 8.3. So you're thinking that you're going to get it like 8 or 9 times. That's approximately what? Closer to 8, maybe 9. But that's how many times you should get a 6 if we have the theoretical probability. So what I'm going to do is we're actually going to try this out. So with a partner, you're going to need a die. If you have one at home, go ahead. There's also like a free roll a die. If you just Google roll a die, you can roll it. But you're going to roll the die 50 times and see what you get. Pause the video, you try it. I'm also going to try it and let's see what happens. Let's see what you get. Let's see what I get. And you can think about it. So I'm going to pause. I'm going to do my numbers and I'll share them with you in a minute. So I actually rolled the die and these are my results. I got 12 rolls of number 1, 8 rolls of 2, 9 rolls of 3, only 3 rolls of 4, 9 of 5, and 9 of 6. So if we want to find my experimental probability of rolling a 6, I actually got 9 out of 50. Oh, sorry guys, that is not what I meant to put there. I'm going to write it over here at 9 out of 50. Which was 0.18. So it actually was a little bit higher than what I expected it to be. But if I was wanting a 4, let's take a look here. This one is only 3 out of 50, which is actually a lot smaller than what theoretical probability predicted it would have been. So here's the formula for experimental probability. It's the number of successes, or the ones that we wanted, divided by the total number of trials. So how many times did you actually do it? So the experimental probability is the number of times you have success divided by the number of times you actually rolled the die. And it will be different. If you did it, you may have noticed that you got more sixes or less sixes than I did, and it would be different than you. Which kind of gets you to the questions over here about what fraction of the outcomes are 6. Share your data with another pair. Of the 100 rolls, how many were 6s? So take your data plus mine and see what happens. Does it get closer to the experimental probability or the theoretical probability or not? Ideally, what happens is the more you roll the die, the closer it gets to that experiment or the theoretical probability. But it's not always the case. It just depends on what happens. Let's move to the second page. And here we can look at another example. Erica tossed a coin 50 times, recorded her results in a frequency distribution table. So heads, it looks like she got 22, and for tails, she got 28. What are the experimental probabilities in Erica's experiment compared with the theoretical probability? So theoretically, if you're going to toss a coin, you are expecting to get 1 out of 2 times a heads, 1 out of 2 times a tail. Because there are 2 choices. So it's 50%. Or 1 out of 2. Now, in this case, for heads, she got 22 out of 50. Which becomes 0.44. Or 44%. So notice that her chances of heads were actually less than the theoretical probability of it happening. And the tails, she got 28 out of 50, which is 56%. So it was actually higher. So the chances of getting a tails for her was actually higher than what she expected. So be careful of that. That is the difference. On to the last question. This is one where you might have to try it as well. But there are 4 suits in a deck of 52 playing cards: hearts, diamonds, clubs, and spades. Suppose you draw a card at random from a shuffled deck. What is the theoretical probability of drawing a heart? Now, this, again, you can go online to one of those websites that I gave you. I think it's the first or second one, but you can actually draw cards, and they draw them one at a time and they just put them back, which is ideally what you would be doing. So try one of those to finish this question of the day. Lots of probability simulations online. You just have to do a quick Google search. I gave you a few, but you can also do some looking if you want. There might be apps for your phone as well that you can try. It's really up to you what it is you want to use and what's easiest for you. I'll try and get some videos if I can to show you, but right now it's pretty self-explanatory. You just go to the website and it's all there. You just push pick a card, and it works. So try them out and see what happens, and then see what happens in this when you pick 40 cards. Do you get 10 hearts, 10 diamonds, 10 clubs, and 10 spades, or do you get something else? And see what happens when you draw even more cards. That's it for today. There's lots of practice questions again and a quiz. So I'll see you guys later.